My name is Chad Hodges. I'm the VP of Business Development for ENS, Enterprise Networking Solutions. We've got a booth out there. I'd love you to swing by, talk to you more about what we are doing with storage as a service with the state of California and all public sector entities around backups, archives, security, you name it. We've got a lot of different capabilities. But without further ado, I want to introduce David McNeely. He's going to be talking today about rethinking security with Zero Trust. He's from Centrify, and he's the VP of Product Strategy at Centrify, where he works with customers to drive the product strategy and roadmap for Centrify's award-winning privileged identity management. On that note, I'm going to give it back to him, and he's going to turn it loose, and we'll talk to you guys afterwards. So thank you very much.
Great, thanks a lot, Chad. So I want to present to you a concept that was created by Google and Forrester called Zero Trust. And then I'll go through a little bit more on just best practices around identity and access management, things that we've been learning from a lot of our customers. But just to recap and set the stage, why are we doing this? It's mainly because there's a lot of attacks that happen today. You're probably familiar with most of these. I think probably the one that's, I would say, is probably one of the ones that affect a lot more of us is probably Equifax. If anybody's ever bought a house, your data is in that system. If you ever have credits, your data is there. And they know a whole lot about you. So if you think about how someone goes and registers to get a new account, they need to know your mother's maiden name, your previous addresses, phone numbers. It's all in that database that now the bad guys have a copy of. So it's more important than ever that we protect identities, because that's how we log in and gain access to servers, applications, services, anything that we use, we're going to use an identity. Part of the problem is that we're also finding a lot of organizations moving to cloud-based services, whether you're adopting Office 365, Google G Suite, using Dropbox, Salesforce, any application that's out there. And then a lot of people want to access those with mobile devices because we're not usually at our desk. We've got mobile phones that give us that capability. We have iPads and tablets. That creates a lot of challenges for IT, just because it's not like the old days where you only provide access to the people that are on the inside of the network, coming from machines that you've locked down and you've got controls around the workstations. So that just simply creates an environment where we have to look at identities and using that as a way to control the access to systems and applications. With that being said, Zero Trust centers around the idea that when I access a server in an application, we don't trust any external security mechanisms. In other words, we don't trust firewalls, we don't trust edge of network, we don't trust authenticated wireless networks. The server has to validate the user and what device the user is coming from before granting access. There may still be an authentication system in play here, depending on how it's architected, but the idea being that a server and or an application needs to verify the user and verify the device coming from before we grant the access. With that, we also layer on top of that this notion that in addition to verifying the user or their device, the granular access and least privilege, that we want to use machine learning as a way to make that a lot smarter so that we can move away from static policies that we would normally have created. Now, verifying the user is pretty straightforward. The idea being, let's consolidate identities as much as possible, give the user one user ID, one credential, and try to use multi-factor authentication where possible. Because if you look at the way malware attacks systems and gains access to networks, they try to reuse the hash of your password if they've been able to penetrate and get onto your desktop. There's a lot of tools that work to try to prevent that from happening. But if it does happen and it somehow gets past those tools, because the bad guys are really smart, they're using a lot of open source tools. And even if these antivirus tools that you've got are looking at fingerprints and things like that, and even hashes of the applications, what they do is they just go back and change one little thing and it changes the fingerprint. So it makes it easy for them to get past some of these tooling. But multi-factor authentication is something that would use a push notification to my phone. Well, the bad guy's not going to have my phone. Or I could have used a secure ID token, or I could have used a smart card or a YubiKey There's a lot of different mechanisms we can use nowadays to challenge the user for something else that the user has to have. I use the YubiKey because it's got a hardened key in the hardware in the silicon, and I have to physically touch it. Well, bad guy that's doing things via software can't physically touch it. It's just human capacitive touch. It's not as smart as a fingerprint, but that makes it really easy to deploy and use within the environment. And then we use behavior analytics to sort of work out, is it really David? I work in Santa Clara, California, and I live in San Jose. So if there's an authentication attempt coming out of Sacramento, that's not David, because I don't work there. That's not normal behavior for me. If I was visiting and it was a business trip, why not just challenge me for MFA? So that system can be smarter and figure out that what my normal patterns of behavior are. And we want to use that to drive the decision-making process instead of IT guys having to figure out and say, if I put this rule in and that rule, it just gets difficult to maintain and manage. We'd like to get the systems smarter and let it do most of the work. With respect to the device, there's also a lot of products that people have put in place, whether it's a device management product, might be just standard group policies out of Active Directory, but things that identify and lock down the device, such that we can make sure it's one that belongs to my company, that's got the right security posture. There's a lot of vendors here today that also have products that check and make sure that it's not running malicious software, that it's got antivirus code up to date. Those things can be tested before I grant the user access to an application. We just simply have to have the right tooling and the checks in place to make sure I've got a correct system. We can also use privilege management as a way to make sure that there's not just an admin account on every machine that's exactly alike across my company. I do find that's kind of common, unfortunately. It's just because of the challenge of an IT staff deploying lots of computers. You get boxes and boxes of them for new employees, or as you're doing a refresh. It's easier just to put in the same password and use it across all the computers. That way all the IT guys know how to log on and get to local admin. But it'd be better if every single computer had a different local admin password and the systems were automatically rotating and changing those on a periodic basis. And if people really need privilege, we can give them very granular, elevated privileges. In other words, I would like to be able to change my Wi-Fi and add it to my home network. Well, that's a privileged operation. So I should have the privilege of just adding my own home Wi-Fi. I don't need to change anything else on the computer, but I want to make it usable at home. Might have to do the same thing with respect to a printer, right? So those kinds of operations you might give to users and hold back everything else. And there's ways to do that. On the application and the server side of things, we're finding a lot of customers wanting to move to a least access model, which means if you were to pull steady state security policies out of the data center, no IT staff or developers or admins would have access to any computers at all. I've got a lot of customers that have done that, moved to that status. But in order to make it work, you've still got to empower people to do their jobs, so you set up request access. And what that means is either making a request to a workflow-based system, such as ServiceNow, SailPoint, you might have another help desk or trouble ticketing system. But make a request to that, route it to the manager or the person, maybe to a security ops staff or DBA staff, depending on the kind of computer you wanted to gain access to. And at the end of the approval, we can grant a limited amount of time access. The idea being, let's give somebody access for 8 hours. It should be enough to get their job done. If they need longer, they can come back and ask for more time. But that way, the set of rights roll off. Now, let's think about it from the bad guy perspective. Bad guy got in and somehow got a hold of your credential. Well, if the steady state is your credential does not have rights to go log on to anything, he didn't get anything of any value. He can't jump off your workstation and get to another workstation. He can't get to a server. And same's true of privilege. If your account doesn't have privileges to do things on databases and file servers and applications, he can't get to any valuable data. So we're trying to make it easy to remove all of these access permissions from people that we would normally authorize. But the reason to do that is because other people have figured out a way to misuse their accounts. And it's not a human at the keyboard anymore, it's a bot. And we're trying to just prevent the bot from doing things by putting, if you combine multi-factor and this request access, those are the two most important things to do in the environment to sort of remove the bad guy's ability to get to other systems. The learn and adapt I talked about a little bit earlier, but this thing is, machine learning systems are based on feeding it a lot of data. They need to see the log data. They need to see all the normal activity. When I'm logging onto my computer in Santa Clara, then they need to see those normal events to be able to work out what's normal activity, what's normal workstation for me. They'll figure out that it's my iPhone has got a unique identifier on it. My laptop has got a unique host name. It's got a PKI credential on it. Those things identify those workstations, and then all the authentications from those specific endpoints come from David. So if I saw Peter logging on with David's laptop, that would raise a red flag. The system would say it's a high risk. We would either block it based on the rule that we say for high risk, either block or challenge for MFA. That would then prevent the bad guy using Peter's account from getting onto my laptop. If you look at most organizations, you know, the Active Directory typical policies basically allow any end user on one workstation to log on to another workstation. So malware knows that. So then what they do is they'll grab the hash of your account if they can get their first foothold on the system, right? And from there, they're going to use your account to go log on to another workstation. What they're doing is they're looking inside each of these computers to see if they can find where an administrator had logged on previously. And what we're trying to do is to set it up in such a way based on the previous request access so that even if they found an administrator account, they still wouldn't be able to jump from a workstation to a server, because that's where usually more data is valuable. And this system, the machine learning can figure out the normal behaviors, normal workstations, so that we can raise the risk scoring and thus either block or challenge for MFA on other activity. It just makes it easier so that you don't have to define as many static policies in the environment. Now, that being said, we've been working with a lot of our customers to come up with 4 pillars of best practices. So identity consolidation, limiting lateral movements, enforcing least privilege, and then auditing all the activity. And it's not a path where you have to start on one end and go to the other end. You know, they're just simply best practices. The more you adopt, the more secure you would be. We actually have a Forrester study where they went out and analyzed a lot of customers and said, how many of these different practices were you adopting? And the more people adopted, the less expenses they had in the environment because they had automated quite a bit of their environment. And also the less amount of breaches happened at those organizations or less data loss. And I've got another statistic at the end of the presentation. I'm just going to go through a few of these categories, but just because like established identity assurance is all about making sure I got the right person and we're granting the right person access to something. But it really starts out with consolidating identities. Now, a lot of times this is actually the one area where people will spend quite a bit of time, just because when you start looking at your environment, Active Directory, everybody has one account. That's pretty easy. IT admins typically have 2 accounts. They have their standard end user desktop account and they have a -A account. But if you start looking at like databases, a lot of times I'll find people have created individual accounts for the end users that need to log into the database inside the database. But you don't have to do that. If you can tell the database, simply use the operating system and or Active Directory as the authentication system for the accounts. Every single database that's manufactured today knows how to use either PAM or LDAP as a way to trust the operating system. The problem is that Linux machines by default don't come with built-in mechanisms to authenticate against Active Directory. Windows machines do, so Microsoft SQL, it just uses AD. And so you don't really have to go create accounts inside Microsoft SQL Server, but you do inside Oracle, Informix, DB2, et cetera, right? If you don't tell it use the operating system. If you tell it to use the operating system, then the operating system trusts the directory. Guess what? Now I only have one place to worry about managing the user's account. He's only got one password. All I got to do is worry about group memberships that translate to access permissions inside the database. It's a very simple change, but it does require people to go back and make a concerted effort to try to clean up. It really impacts, costs when you start looking at onboarding new employees or temporary staff, or the resulting work required to offboard an employee when they terminate or leave. And really, the terminate leave is probably the most important because we don't want orphaned accounts within the environment, right? And if you tie everything back to Active Directory, it makes it a little bit easier. Then your IT staff that are manipulating these accounts only have to worry about managing accounts in the directory, not inside all the applications. So we find consolidating identities is one of the, probably the most powerful thing you can do in the organization as a way to clean up and get a better handle on automating account management across the organization. This traverses not only databases up in the application layer. I would say there's an awful lot of applications today that support federation. And then you can tie it in for federated authentication. Federation systems typically all tie back to LDAP or AD as their source directory. So that makes it very easy for the apps to be able to tie in. We also have the SaaS-based applications, and infrastructure as a service. All of those can be tied back into the directory as well. I've even got customers that have been able to figure out how to use existing tooling built into mainframes and the minis, AS400s as well, to be able to tie those to Active Directory because it supports Kerberos and it supports LDAP. LDAP supports the user lookup directly into Active Directory, and Kerberos, which is GSS API, supports the single sign-on. So workstations that authenticate against AD get Kerberos tickets back. That's how you gain access to your file server, your Exchange, your SQL server, without having to type a password. It's all based on Kerberos, and the mainframe supports that as well. All you have to do is configure it to use LDAP and Kerberos. So you can eliminate a lot of accounts across the entire organization by just focusing on reducing how many places do I need to go provision a brand new employee or a new contractor. I was talking to another customer that, big healthcare organization, we were helping them clean up post-breach, and they have some 90,000 employees. That wasn't really their problem, the 90,000 employees, because overall they have over 150,000 people that work for the organization. The rest of that number, 60,000, is contractors. They come and they go every other month. So they've got huge turnover and churn that's happening in the contractor staff. That's where the real burden was. Not necessarily employees, but the contractors. And you've got to go through the same provisioning process for contractors just like an employee. And then when they leave, you got to take them out. What you don't want to have happen is the contractor to come back and find that all of his accounts are still there. Or worse, he left on bad terms and was able to get back in because you didn't disable the accounts. So the next step, obviously, once you've done that tied everything back into a single repository, it makes it so much easier to go back and provide single sign-on. Again, if we could tie it back to Active Directory, we're using Kerberos. That provides single sign-on. I logged onto my desktop, and then from desktop I can get to all the things that support IWA, Integrated Windows Authentication, or Kerberos-based authentication. Some things like to use PKI. Other applications would use SAML, but all of these mechanisms are strong authentication. We start looking at multi-factor authentication ties into this particular story because one of the things that we use as far as guidance on MFA is NIST documentation, the special publication 800-63. It describes assurance levels. So there's assurance level 1, which is like a password. Assurance level 2 is multi-factor. I have to have something in addition to knowing something. Assurance level 3 is it's got to be hardware crypto, like a smart card or like a YubiKey or a FIDO key. But it's a physical chip that's going to protect my private key. Now, federated authentication or single sign-on actually is still at assurance level 2 because I have to authenticate in order to pick up one of these other mechanisms. So if I'm getting a SAML or a PKI or Kerberos, that's a federated authentication credential that I got after I did a real authentication at the desktop. And that's considered assurance level 2. So it gets you to higher security just by adopting single sign-on. But that goes hand in hand with how did you authenticate the user. So I have some customers in federal government that are required to use smart cards via HSPD 12. That was enacted ages ago. There's obviously challenges deploying smart cards because typically it's a card that's going to get you in the building and it's going to have your photo ID on it and it's going to have a chip that lets you get onto your computer. The problem with all of that is obviously the issuance process. I got to go talk to a badging officer, they got to take my picture, print it on a card. issue the credential that's going to get you in the building, and then go put a PKI credential on it. And in order to use it on my laptop, it's either got to have a built-in reader. This one doesn't have a built-in reader. Some do, if you order it that way, but if it doesn't, you're going to have the USB thing that's got to plug into the side of it. So that's just complicated. YubiKey made a device that acts like a smart card, but it just plugs into a USB port. They have them for standard USB and the USB-C ports. That's one way to do it. All you have to have is a PKI-based infrastructure. But another standard is the FIDO standard, U2F, which still uses a key that looks just like the YubiKey. The difference is it doesn't require certificate authority. So it can generate a public and private key on the device itself. And all I have to do is register my public key with the application in order to get authenticated. The cool thing is that you still get assurance level 3 like a smart card without all the rest of the back-end infrastructure, without a badging officer, without the issuance process. It's all self-service. It's pretty easy to deploy. But it still requires you to carry something. And I've heard from some customers that say, well, the user is going to forget it. They're going to leave it at home. It's just not going to work. So what we design is a mechanism to support different mechanisms so that the user gets to select out of a list, which one of these things do I want to use? You could select FIDO if he has it with him. It's pretty easy because all I got to do is type in my user ID password and touch it. And the magic happened and I got on the system at assurance level 3. The other way is just do a push notification to your phone. And then what's going to happen is I got a fingerprint unlock, swipe across and say yes or approve. And that's going to get me into the system. So that's pretty easy because a lot of people have a phone. They keep it with them. It's not very difficult for people to keep up with their phone. They probably keep up with it better than their keys to their car and other stuff. They probably keep it powered up better. But then again, some organizations may not have that. And I've got some customers that are in environments where they can't take anything with them electronic inside the organization other than a hardware device like a RSA Secure ID token. Those are supported as well. It's just a different mechanism. The goal really is how many places can I apply the multi-factor? And let's make sure that I can cover everything. Applications, my desktop, servers, VPN, everything that we need to be able to control access to make sure that when bots try to knock on the door and try to log in with the user ID password that they stole, that they can't get in unless they have the multi-factor. And then that does a pretty good job of preventing the access. Now once they've gained a foothold, the next thing we want to do is prevent lateral movement. That's best done by two different approaches that we have. One is setting up groups of systems that you can gain access to, and then the other is using request-based access. I talked about request access before, but this is just a mechanism to group together systems based on role. We typically grant users, we think about roles with respect to users. I've got people that are DBAs, that's a role. I've got web administrators, I've got IT staff, I've got help desk personnel. Different roles within the organization grant different set of rights. It'd be easier if I could say the DBAs have access to database servers. And that means I need to categorize servers into roles as well. If I do that, and maybe a little bit more granularly than that, like the PCI servers separate from the rest of the servers, it makes it easier to define the rules that I want to provide. But it still grants a pretty broad set of access permissions, which is why I find people adopt this, but then rapidly try to move to the request access. It's in a different slide. But one of the other approaches that we've found popular is pushing people towards eliminating, as much as possible, use of a VPN. The session right before this one, I think he talked a little bit about the Target breach. If you don't know how that happened, the HVAC contractors had permission to go VPN into every one of the stores at Target in order to go monitor the temperatures. They monitor the HVAC systems. So the malware bad guys attacked the HVAC contractor. They got malware onto the contractor's workstation. Those workstations VPN'd to the network, and now they were just simply using those credentials to traverse across and get onto the HVAC system. Now that they're on the HVAC system, they scan and they look for admin accounts like a sysadmin. They find one. They can get from there into other servers that are at the store. So now they're off the HVAC systems onto other systems. And then, of course, the story goes they keep going and they breach the point-of-sale systems. The point of the message is that they traverse the link by the VPN. Because VPN didn't prevent their access to other systems, those HVAC contractors had legitimate access to get to that network and access those HVAC systems. But if they'd done it with an application layer, not network layer connections, they wouldn't have been able to jump across the link. Because they're using tools like PowerShell and scripts and that kind of stuff to try to log into other servers. If we'd done it like, let's say if you'd had Citrix VDI at the edge, or if you'd done a web reverse proxy at the edge of the network instead of a VPN, that would have prevented the access. We've built those kinds of capabilities into our products, but just adopting anything that does application layer instead of network layer is best practice at the edge of the network. Passwords are not just human passwords alone. I also find an enormous amount of systems where an application needs to go log on to another application. It's very common in a web application that it's multi-tiered. The web tier needs to talk to the database tier. Or maybe web tier talks to compute tier, and compute talks to database. But how they talk is still with a password or a credential of some sort. It's best if we can remove the password. In this case, there's a password being passed in. You can see the password there. It's being used inside the script. In the other example, we're using a command to go retrieve the password out of a vault instead of having it buried inside the script. Because if the script got out, and it's kind of common that people like to copy their scripts up to their Amazon S3 buckets, and hence the bad guys scan your Amazon S3 buckets looking for scripts that have passwords embedded. So it's better if you do something like the latter, which is put a command in there that's authorized for that computer to go talk to your vaults, to go retrieve credentials. Right now it's based on an authorization for a computer inside your company, not the bad guy's computer that stole your script. Because if he stole that script on the right, he doesn't have anything, no passwords. And then, of course, least privilege. You have admin accounts for every single computer. The goal here, though, is to try to, as much as possible, make sure that every computer has got a different local admin account, that it's under really tight management. That puts it into a password vault of some sort. I would further say that we want to try to prevent, as much as possible, IT staff from having to break glass and access that vault. They actually should never break glass and access the vault unless it really, really is dead, single user mode, it can't access the network, and it cannot authenticate to a directory. That's when it's okay to go break glass. But I've talked to a lot of our customers, even Wall Street banks, that have said, you know, the problem is IT guys are breaking glass all the time. That's their standard procedures, is to make a request, go access the vault, check out a password, now I use it for the whole day. Or what my consultants find is they went to the password vault, they checked out the root password, they went to the machine, and they dropped off their public SSH key, and then they threw away the password and said, fine, I never need to use that vault again. I'm just going to use my SSH key to get from my desktop to the server. And at that point, I just bypassed all of your security controls, and I'm on the box as root, and you can't tell what I'm doing, because it looks like the root local admin account is doing stuff on the box. And therefore, we have no accountability. And worse, if you go back and look at the server, you see all these keys, and you're like, okay, who has the key? Who's got the other key? You have no idea. It's a label that tries to identify who the user is, but it's not required. So the key's just a string of, it's like a hash. You're never going to figure out who the user is that has the key that can gain access. Let's hope it wasn't the contractor that you terminated on bad terms. So for that reason, we try to provide IT staff with the right tooling to enable them to log in using their own account or maybe a -A account, and then give them elevated privileges for the task at hand. And by doing that, you can limit what it is that they're authorized to do. So in this example, you can log on, you can restart a web server. That's not risky. It's just restarting a server, right? But if you wanted to do something that's risky or that might potentially alter the system, any editing commands or anything that might change it, at that point you need to privilege elevate, sudo. On Unix, Linux machines, we have privilege elevate capabilities on Windows machines that do the exact same thing, but at that point, I can challenge somebody for MFA to make sure that it's not a bot running the sudo command, because a lot of bots know about sudo and some of the other commands like it. This way I can make sure it's still a human at the keyboard and not some script that's being run by some attacker remote off network. But then you can move to the request access model to further reduce the risk, the footprint, right? This way I can go into, so I have a lot of customers using ServiceNow as their help desk system. And the idea is that if you've got IT staff that log on here and then they see a list of trouble tickets, they're just going to pick the next ticket and I need to work on it. It says I need to go fix this server over here. So at that point, we can automatically approve their access permissions to that server, give them elevated privileges and rights for that duration of time for that ticket. It's all associated with the ticket. And then when the ticket's done, it closes and it removes their rights. So they never left this tool. They didn't have to go to a password vault. They didn't have to do anything different. But we gave them a link to go log onto the server, and we can audit the activity, and it's tied to a trouble ticket. Now, if auditors come in and ask you anything, you say, here's my log. Just point to the change control system, and it's got your list of all the trouble tickets. And here's when they logged on. Here's the activity they did. It's all correlated. It just makes it a lot cleaner for you. I have people using ServiceNow, SailPoint. There's a number of different tools that can do the workflow on that. Then it's just a matter of hooking that up to our system that grants the access rights at the end of the approval process. And that could be automatic, or it could be route something to my manager or route it to the SecOps team. Really depends on process within the company. Final topic is auditing. And with auditing, I do find a lot of customers that have SIM systems absolutely log everything. It's actually even more important when you start moving out to AWS, Azure, GCP, those kinds of hosted infrastructures to be able to log all the activity. Mainly because everything's driven by your keys that you use to gain access. And again, federate in order to minimize risk on those keys. But this is another way to monitor the activity. So if you think about all of the software that ISVs like us create, my engineers in the code said, if my debug level is at info, then write this to the log. If it's at debug level, then write more stuff to the log. The problem is you're not in control of much other than is it an info level or debug level or warn level. So you have a few different controls there. But if somebody logged on and ran, like, let's say the VI command to edit a config file that's going to change how your web server works, well, VI doesn't have any things that it's going to go right to the syslog. It's just an editing tool, right? So what the idea here is that we can record everything that happens, everything that you type, everything that you see on screen. If you logged on and ran VI, we see everything. If you logged on and ran SQL exec and started browsing the database looking for credit card numbers, we're going to see it. It's going to get captured. It gets sent off to a system that's going to analyze it. There's no way around it if this is implemented host-based. In other words, the host that you're trying to protect is going to record everything that comes into him. So he doesn't trust things on the network. And that's the most secure way to do it. We also have built in a little bit of process level monitoring because, again, bad guys, if you think about setting up controls that prevent people from running commands you don't like, I'll just put it inside a script and I'll launch the script because that kind of hid it from your thing that's a shell level that's going to control what commands you type. But this way we can monitor processes that get launched or monitor files that might be changed in the /etc directory. Or you might be running tripwire. All are good ways to make sure that people don't change the security posture and the security controls that are being enforced on the systems themselves. And if you roll that up to SIM systems, it just creates more data that the SIM system gets to operate on top of, right? More visibility. So I had some customers that had DBAs that would log on, and then they would switch to the Oracle accounts as they were doing work on the Oracle servers. The SecOps team was watching their, in that case it was an ArcSight deployment. They had a bunch of guys watching their logs. And they said, we got somebody doing something wrong in this database. We need to tell IT to go smack the guy, go grab him and tell him he's doing something wrong, figure out what it is. The problem is with two guys logged on, switch to the Oracle account, you really have no idea which person is doing the work because when you look at the logs, it said David logged on and Jim logged on, but then it said Oracle's doing this, Oracle's doing that. So Oracle logs all said Oracle's doing stuff. You didn't know which one was doing it. Now, if you implemented the process monitoring I showed before, then you have David logged on, and this is David's session that looks like Oracle is doing stuff, but it's all attributed to David's session. So it clearly indicates David's doing this activity. Even though I might have been doing it as the root accounts, it's still David's activity. And that clearly indicates that it's David versus the Jim guy that was doing bad stuff. So it's different things layer on top in order to try to create a better secure environment. They all go hand in hand. I find different people are on different places in their journey of getting more secure. And there's no right or wrong as far as which one to implement first. It's just a collection of best practices. Again, like what I said before, is that Forrester did a report of a couple hundred customers that were implementing these best practices, and the more best practices they implement, the better security posture they had. Those that implemented the majority of those best practices had 50% fewer breaches, cost them $5 million less, both in operational costs because they'd automated a lot of things, and also because breaches are expensive. If you can consolidate products and get one or two products to do more of the work, you end up having to do a lot less work, especially as you start consolidating. So think about if you buy like 4 or 5 products, then you're going to have to set up roles and how do I authenticate people into these. Each product is different, and then each product's going to create logs. The more you consolidate, the less of that kind of duplicate work you have to do in order to manage the systems. So we're starting to find some consolidation into platforms, is real benefit to organizations. And with that, I think that's my last slide. So I'll open it up for questions if you have any questions. Otherwise, hopefully they'll have beer ready soon.
Good question. I still want to know your slides that has the VPN. So when you're coming to a VPN and then you have Centrify in the middle, so you are allowing only the specific applications, right? So currently we have a product that we use for vendors, specifically for water treatment plant SCADA networks. So we use some approach to do exactly that. So I wasn't sure if that's what you do there, or it's just
Sure. So basically, this is a SSH and RDP gateway. So we implement this in such a way that you can gain access to a web-based portal. You select a server you want to connect to, and then tell us how you want to authenticate, whether you need to break glass and use the root account, or if you want to log in as yourself and use privilege elevation. But out here, you only need a browser. Now what I'm finding is a lot of organizations have outsourced IT support and or outsourced application developers, the two most common use cases, because I don't run across too many people that have outsourced HVAC, but I just haven't seen the use cases. At any rate, these users don't need anything on their desktop. All they need is a browser. They do need to strongly authenticate to our system in order to see the portal and then select a server. But all of that's based on roles and permissions that they have. And then I can still show them RDP to a server or SSH to a server back here on their browser that's tunneled through the connection here at the application layer down to the server. And then the location of the server doesn't matter. It could be on premises in the data center, or it could be out on AWS or Azure or Google. Based on the architecture of the system, we have these things called connectors that provide the connectivity to the target system using SSH in the last mile. Otherwise, it's all HTTPS tunneled traffic from this endpoint all the way to the connector that's closest to that server. Now, the same is true at the application layer above. What we're doing there is basically just using a cloud service that acts like a giant reverse proxy. You may already have something like F5 or other things that provide reverse proxy at the edge of the network, just like you might have a Citrix system that does this for the RDP traffic. They all provide the similar kinds of capabilities. It's just we felt like it was necessary to provide that, mainly because if I wanted to get to, and I use Jira a lot to communicate with my engineers, stories on improving the product, I can use my phone to get to it. And I just have to select the application and swipe across and gain access to the Jira application. I don't need VPN on my mobile device. And what I'm doing is I'm just tunneling through that the application layer. It's HTTPS from phone to the to the Centrify system, and then from here it's HTTPS out to the application, using SAML to authenticate me to that application on the target system. But in order to prevent the bad guys from getting onto the network, we would just simply advocate using application layer as much as possible and eliminating VPNs on mobile devices. There was another announcement of another attack on Android, malware, and so if you have VPNs configured on the device and malware's on the device, and your malware detection system's not up to date, it could traverse the link. Outsourced IT, outsourced contractors, where are they working? What's the security posture of their workstations? It's outside your control. You don't know, right? So that's another reason to not necessarily trust these guys. I mean, you have to enable them to do their job, but you can minimize your risk by saying, okay, I don't trust your IT guys and your workstations here. I'm going to let you come in via application layer as opposed to network layer. Anyway, we do have a booth. If you'd like to talk further, we'd love to talk with you. Otherwise, thanks for coming.